Good evening, everyone. Yesterday we were discussing about the covalent bonding, the bond which is formed by sharing of electron, as well as the dative bond. And covalent bonds are of two types. A simple covalent bond, it can be non-polar covalent bond, or it can be a polar covalent bond. So when the bond is formed between the two or more non-metals, then this polar bond can be categorized as uh, polar or non-polar. What is the difference between polar or non-polar? Because non-metals have the tendency to attract the electron, to attract the shared pair of electron. So we have hydrogen here, example, bonded with another hydrogen. So both have the tendency to attract the shared pair of electron, as these atoms have the same tendency because identical atoms are there. So the bond pair, which is, or the shared pair between, which is between the two atoms, will be at the center. So when the shared pair is there between the center, or it is shared equally, that is known as non-polar covalent bond. But what about the polar covalent bond? What happens if it is formed between the two non-metals which have different tendency to attract electron? Like example, we have hydrogen bonded with the fluorine. So fluorine is having a greater tendency to attract the bonded pair, the shared pair, as compared to that of hydrogen, because there are more protons and smaller in size, so it has greater tendency. So what happened to this electron pair which is shared between the two atoms, that is shifted more towards fluorine. The side of fluorine, this shared pair is more. So what it create a partial negative and a partial positive. So it create poles ends of positive and negative. That's why this type of a bond, in which the bonded pair is slightly shifted toward one of the atom, we call that as a polar covalent bond. And the tendency of an atom to attract the shared pair, that tendency is known as electronegativity. So tendency to attract the shared pair of electron, that's called electronegativity. And as we go down the group, the electronegativity decreases because the size is increasing. And as we move across the period, the electronegativity is increasing because the nuclear charge increases, so attraction also increases. So the element which is the most electronegative, that is fluorine. So when the electrons are shared between the two atoms which are having a greater difference in the electronegativity, so electron pair is shifted more towards the atom which is having a greater electronegativity, and it creates partial negative and positive. And due to this partial negative and positive, this is a covalent bond, this is a sharing, but this type of a sharing in which unequal distribution is there for the shared electron shifted more towards one of the atom, we call that as a polar covalent bond. Is it clear, the concept of the polar and the non-polar covalent bond? Any doubt till this point? So when we compare the nature, like example, we have hydrogen fluoride, a bond between hydrogen and fluorine. Then there's a bond between hydrogen and chlorine. and then there's a bond between hydrogen and bromine. So this is a covalent bond. This is also a covalent bond. This is also a covalent bond. But which bond is the most polar? So when we compare, hydrogen is same. So when we compare the electronegativity, the tendency to attract the shared pair of electron, that decreases as we go down the group. So as the electronegativity decreases down the group, fluorine is more electronegative, so it will have a greater tendency to attract electron. So this will be the most polar. All will be polar, and this will be the least polar. So there will be partial negative, positive, but the one which will have a greater distribution or unsymmetry, that is in case of hydrogen fluoride compared to hydrogen bromide. So basically when two atoms have the same electronegativity or identical or similar electronegativity, the bond likely to be non-polar. But if there are two different atoms which have a difference in the electronegativity, then the bond's likely to be polar. So now we'll do some questions related to the bond angles. Yesterday we discussed the bond angles as well, geometry and the bond angles using a valence shell electron pair repulsion theory. This is the intermolecular force, but we'll do shapes of the molecule first. Intermolecular force is force between the molecule that we will discuss in unit 2. In question 4, which compound contain a bond with the greatest polarity? So how to work out the polarity? All are bonded with hydrogen, so we don't have to check hydrogen. Basically what we have to check nitrogen, fluorine, carbon. So when we check the position in the periodic table for these elements, so this is a periodic table. All are bonded with hydrogen, so we don't have to check hydrogen, we have to check other element. So there is CH4 is there, carbon is there, nitrogen is there, oxygen is there. One of the option was water. Yeah, oxygen is there, and we have fluorine. So what happened, as we discussed the electronegativity, when we move across the period, the electronegativity will increase. So they will become more electronegative. So when we check which bond will be the most polar, so the most polar will be hydrogen fluoride. Then about the molecules, a covalent molecules can be classified as two. It can be classified as non-polar molecule and it can be classified as a polar molecule. If it is a non-polar molecule, then two possibilities are there. Maybe the bonds are also not non-polar, and maybe the possibility is bonds are polar but overall molecule is will be non-polar. And how we can distinguish whether a molecule is polar or a non-polar molecule? A non-polar molecule, it does not have any resultant charge, so it is not deflected by electric field. Whereas a polar molecule, it when we pass this through a electric field, so it is deflected by, or when we pass through the electric field, so it is deflected by the electric field. That's the main difference between a polar molecule and non-polar. So covalent molecule, simple covalent molecule can be classified as a polar or a non-polar molecule. If it's a non-polar molecule, then it might have two possibilities. The bonds will be non-polar and molecule itself will be non-polar, or it might have polar bond but it will be a non-polar molecule. So how we can work out example? The first example, a non-polar molecule with non-polar bonds. What is the example of this type of molecule? If I say hydrogen, H2. So hydrogen, when we compare the bonds, because two identical atoms, same electronegativity, so this electron is evenly shared between the two atoms. So what about the bonds? The bonds are non-polar. And what about the molecule? Because if bonds are non-polar, then this molecule does not have any resultant charge. It does not have a charge on it. That's why it is not deflected by electric field. So overall molecule will be a non-polar molecule. But example of a molecule, a non-polar molecule with the polar bonds. So what is the example of the non-polar molecule with a polar bond? Example, we have methane or carbon tetrachloride, CCl4. Here it was H2, now we have CCl4. So what happened in CCl4? Carbon is bonded with 4-chlorine, and when we check the electronegativity, when we check the periodic table, you can see chlorine is there which belongs to group 7, and carbon is there which belongs to group 4. So carbon will be less electronegative as compared to that, because when we move across the period, the electronegativity increases. So chlorine has a greater tendency to attract the shared pair of electron. So what will be the charge on the chlorine? As this will be partial negative, partial negative, partial negative, partial negative, and the charge on the carbon will be partial positive. So what happened? Basically, these chlorine atoms are attracting the bonded pair, but because the molecule is symmetrical, so if I say, like example, if I have a box and that box is experiencing 10 Newton from left, 10 Newton from right, 10 Newton from top, and 10 Newton from bottom. So what is the resultant force on this box? So resultant will be 0. Same thing happen here, that because the chlorine atoms each are attracting the electron pair, so the resultant shifting is, because the molecule becomes symmetrical, so there will be partial positive and negative, but overall molecule What happened to overall molecule? This overall molecule does not have the resultant charge or distribution of the charge. So this molecule will be, this will have a polar bond. Why polar bonds? Because between two different atoms. But what about the molecule will be a non-polar? Why the molecule is non-polar? Because overall the resultant dipole moment, this is a term which we use when two different atoms are there attracting the electron. One is attracting more than the other, so there is a distribution of electron, and overall resultant is the dipole moment or overall shifting of electron is zero. That's why we call that molecule will be a non-polar molecule. Is it clear? The concept, the difference between the polar and the non-polar molecules. So a question related to that part. Which compound has a polar bond but overall molecule is non-polar? So there should be a symmetry. When we draw carbon monoxide, oxygen is more electronegative. So as oxygen is more electronegative, then electron pair shifted, so bonds are polar and overall molecule will be polar. What about hydrogen sulfide? Because two bond pairs and two lone pair, it will be a bend, and sulfur is more electronegative, partial positive and partial negative. That's why it will be a polar bond as well as a polar molecule. About PCl5, they're not able to cancel out because it's not symmetry. So that's why it will be PCl3 as well. The same idea. When we have PCl3, so phosphorus is there and 3 chlorine. So they're not able to cancel out each other. But what about tetrafluoromethane, which is CF4? Fluorine is more electronegative than chlorine, so this will be partial negative, 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 and carbon will be partial positive. So bonds are polar, but overall molecule will be a non-polar. That's why D is the right answer. Is it clear? Discussion. Then the next part, state the bond angle and shape around carbon atom in diamond. So as we have discussed in O levels, that what is the structure of a diamond? The diamond is having, we say, each carbon having a 4 covalent bonds. So when each carbon is forming a 4 covalent bond, so how many bond pairs are there? There are 4 bond pair and there is no lone pair. So if there are 4 bond pair and there is no lone pair, then what will be the geometry or what will be the structure? It will be a tetrahedral structure, and when it is tetrahedral structure, the bond angle will be 109.5. So this will be 109.5 degrees. What about the shape? The shape will be tetrahedral. And justification, it's a 4 mark, so justification, You will score 2 marks after mentioning the bond angle and the shape. Then justification should be there in terms of electron pairs. So we mentioned there are 4 bond pairs or 4 areas of electron density around the carbon atom, and the repulsion between the electron pair, to give them minimum repulsion, they arrange themselves in a maximum distance from each other. So 4 bond pairs, they all repel each other, adjust to maintain or to keep maximum separation. That's why this is having a bond angle of 109.5 degree or tetrahedral structure. Another question, the simplified diagram to the left hand box shows bonding in hexagonal boron nitride. So boron nitride, basically like different molecules of boron nitride joined with each other. In the right hand box, complete a dot and a cross diagram show only the electron around the nitrogen atom, which is labeled as asterisk, and use cross to represent electron of nitrogen and dot to represent the boron electron. So we have to show how electrons are there between boron nitride, how electrons are shared. So as you can see, there is a double bond, and we have to make the structure stable. That's the first thing. So example, if nitrogen shares one, hydrogen will boron will share one from that side. If nitrogen shares one, boron will share one from that side. If nitrogen share one, boron will share one from that side. But you can clearly see there are 2 covalent bonds between them, and it can be one of them can be dative covalent. It does not make difference. Boron having 3 electrons, so this boron already shared 3, but you can see 1, 2, 3, 4 are there. So how we can adjust? Nitrogen is having 5 electrons, so 3 shared as a simple covalent, and one of them, this nitrogen, will share as a dative bond. So you can draw a structure in this manner, it is acceptable. Or there is also another way. What you can do, if boron share 1, nitrogen share 1, boron share 1, nitrogen, so we finish this double bond. Then nitrogen share 1, boron share 1, so we finish this bond as well. How this bond is formed? So if both of the electron are shared from boron, then this can be a possible structure. But the difference here, these bonds in which equal sharing electron belongs to both atoms, that's the simple covalent, but the other one, the electron only belongs to bromine, that's a dative covalent. Is it clear, this is structure? And here I can also draw, because cross is for nitrogen, so nitrogen is having 5 electron, I have to show those 5, 1, 2, 3 and 4, 5. So this can also be the structure. By mistake I use a dot, it was not boron, it is supposed to be nitrogen. Is it clear? This is structure. Any doubt? Then question 8, this question is about the fluorides. BF3 is there, NF3 is there, OF2 is there and O2F2 is there. For BF3, name the shape of a molecule and give the bond angle of FBF. So how we can work out the bond angle? If it is BF3, first you have to draw the structure, because in BF3, if boron is having 3 electrons, so it can share 3 only. Some exceptions are there. It is not able to complete its octet with a simple covalent. So BF3, this is the structure. So there are 3 bond pairs and there is no lone pair. So we have 3 bond pairs and there is no lone pair or 0 lone pair. So how to predict, to know the structure? This is a table which you have to learn, that if it is, there are 3 bond pairs are there and there is no lone pair, then it will be a trigonal planar with a bond angle of 120 degrees. So we should write here that it will be trigonal planar. And the bond angle should be 120 degrees. For NF3, the molecule, we have to draw the shape you expect and suggest the first one we have to name the shape and the second one we have to draw. So how to draw the structure for NF3? Because nitrogen belongs to group 5, so there will be a 1 lone pair and 3 bond pairs will be there. In case of NF3, nitrogen and there's a lone pair. So it is having 3 bond pairs and 1 lone pair. So whenever a geometry, a molecule having 3 bond pairs and 1 lone pair, then what will be the structure? That should be trigonal pyramidal, and this is how we should draw. So how I should draw, because this is a 3D, like one of them is in, one of them is out, and one is in the same plane. So when I draw the structure in exam, when you draw the structure, like one of them is out, one is in, and one is in the same plane, and there is a lone pair of electron. So the shape we already drew. And what about the bond angle? 3 bond pair, 1 lone pair, it will be 107 degrees. Then what about the explanation that why it is having this structure? So you will always mention that electron pairs are repelling each other. So for minimum repulsion, they will occupy, or they will have the maximum separation. So with this number of the bond pair, this is the maximum separation. So it's a journal answer. The explanation here, for to minimize the repulsion, they have maximum separation. Another question, between BF3 and NF3, identify type of bond that form between the two molecules. So type of bond, it's of 2 marks. So that is a simple covalent bond. And the previous one will mention minimum repulsion for maximum separation, that is 1 mark, and will mention the lone pair repulsion are greater, that is why the bond angle will be shorter. And identify the top type of bond that form between the two of these molecules, so that is simple covalent. Next, we have complete a diagram with dot and crosses to show the outer shell electron in a molecule of O2 and F2. Fluorine belongs to group 7, so it will share 1 electron. Oxygen belongs to group 6, so it will share 2 electrons. So how the structure will be? So when they say dot and cross, it can be alternate. Like example, if I represent fluorine belongs to group 7, so it will share 1 and unshared will be 6. And oxygen belongs to group 6, so it will share 2 and unshared will be 4. So 1, 2, 3, 4, 5, 6 and 7. And then this is oxygen. So 1, 2, 3, 4. And one is shared here, one is another side. Then we use a cross because it can be alternative. One atom you represent by a dot, another one you can represent by a cross. Even though they are identical or even they are different, you can use, if they did not mention, because in this question they did not mention, use dot to represent fluorine and cross to represent oxygen. They did not mention anything like this. So what we can do, we can use alternate dot and cross. Like for if one atom we use dot, other one will be cross. So I can use a dot here, two lone pair and two bond pair. So this will be the structure of O2 F2. Next, which of the following would you expect the pair species to have different bond angles? So basically, you simply have to identify the number of the bond pair and the number of lone pair, and using that you can work out whether they will have the same bond angle or they have different bond angles. So when we check H2O, oxygen is a central atom, and NH2 with a charge -1. So H2O, oxygen is a central atom, so it will share one well electron with hydrogen, and there will be, so it is having two bond pair, two lone pair. What about NH2 with a charge -1? So when charge is -1 means nitrogen gain electron. Nitrogen is having 5 electrons, but charge -1 means it gain one extra electron. So it's like same like oxygen. So this is the structure for NH2. So they will have same number of bond pair and lone pair, so they will have the same geometry, which is a V shape or a bend structure. Ammonium and CH4. When we check ammonium, yesterday we discussed there's a dative bond in ammonium ion, and in CH4 all are covalent bonds. So 4 covalent bond, 4 bond pair, and there is no lone pair. It will be a tetrahedral with a bond angle of 109.5. What about option C? When you check BF3, so boron is having 3 electron share 3, no lone pair. But what about NH3? Nitrogen is having 3 bond pair and there is 1 lone pair. So as the number of the bond pair and lone pair are different. So for nitrogen it will be trigonal pyramidal, whereas for BF3 it will be trigonal planar. That's why C is the right answer. Is it clear? Then another question, covalent bond length. How we define a length of a covalent bond? So the statements which explain the bond, the distance from nucleus of one atom to the outermost electron of another atom, or the distance from nucleus of one atom to the nucleus of the other atom, that is known as a bond length. Like when we compare, if we have hydrogen having one proton and this is also one proton, so they share electrons with each other. So according to first statement, state the distance from a nucleus of one atom to the outer electron of other. It means it is talking about this distance. But that's wrong. This is not the bond length. Bond length is actually a distance from nucleus of one atom to another. That's the bond length of a covalent. So statement B is the right answer. About C, shortest distance from outermost electron of one atom to the outermost of electron of other. So means the distance between the two electrons, that's not the longest distance. This electron can be far apart from each other, but that is also not the bond length. The bond length, the covalent bond length, is the distance from one nuclei to another. That's called a covalent bond length. So they give you the electronegativity table to work out. This is a poly's electronegativity values. The question was, which compound has a covalent bond with the greatest polarity? How to know the greatest polarity? The one which will have the greater difference in the electronegativity. The one which will have the greater difference will have the most polar bond. So when you check for hydrogen and fluorine, they will have the greater difference. That's why their bond will be the most polar. Which compound has the most, which compound is most ionic? Ionic is between the metal and non-metal. So we have to check, because the first two options, as here you can see lithium oxide, magnesium oxide, aluminum fluoride and sodium fluoride. So when we check the difference in the electronegativity, which is having the greatest difference in the electronegativity, when you check sodium with fluorine, that will have a greater difference. So when greater difference is there, the electron are actually transferred and this will be the most ionic. Why it is not B? Because the magnesium and oxygen, when we compare, they will have a small difference, 1.2 and 3.5. But this is 4 and 0.9. That's why D is the right answer. Is it clear? Question 12. Because the most polar bond, if there's a covalent bond, greater difference in electronegativity, most polar. If it is ionic bond, the greater difference in the electronegativity will be the most ionic. So this was exercise related to bonding and shapes of molecule. I'll share this exercise as a weekly homework so you can solve and ask your doubts.